G'day mate, how are ya? I'm Tammy Bryant Butow and this is Tech Tales. Welcome, pull up a chair, get cozy. Today we're going to be talking about Kubernetes. What is Kubernetes? Let's explore the history of Kubernetes going back to 2014. We'll also deep dive on the different components of Kubernetes, so at the end of this video you'll have a good understanding of what it is and how you can use it. Come on, let's go! So what is Kubernetes? If you ask that question on Twitter, you'll get a whole lot of different answers, like a state of mind. But really, what is Kubernetes? Kubernetes, or K8s, is a system for automating the deployment, scalability, and management of containerized applications. I've been using it myself since 2014. It's definitely improved over the years, and I'm excited to share with you a deep dive on Kubernetes. Kubernetes was initially released on the 7th of June 2014. The original Kubernetes system was designed by Google engineers and then open sourced. Kubernetes is the Greek word for pilot or governor. The Kubernetes system was originally created by Brendan Burns, Joe Beda, and Craig McLuckie. There were many other engineers who helped create Kubernetes as well. You can find them on the GitHub repo. There's thousands of engineers who've contributed to the Kubernetes project from all over the world. The Kubernetes system was designed and developed with heavy inspiration taken from Google's Borg system. There's a great paper that you can read about Borg, which is free to download. Many of the people who contributed to Borg also contributed to Kubernetes, the open source project. The original Borg system was written in C++, but Kubernetes was rewritten in Go, or Golang, Google's programming language that they created. Let's dive into the control plane. The Kubernetes control plane is the main controlling unit of the system. It enables workloads to be controlled and managed across the entire system. Let's talk about some of the key Kubernetes control plane components. There's a really great diagram on the Kubernetes website that explains this clearly. On the control plane, we have the scheduler, etcd, the Kubernetes API, CM, and CCM. Let's dive into a few of these. First, let's chat about etcd. etcd is a lightweight, persistent, key-value data store. Originally, it actually was created as part of the CoreOS project. CoreOS is something that I also used back in 2014 when I was working at DigitalOcean. It's great to see that the CoreOS team then worked with the Kubernetes team to be able to implement etcd technology within Kubernetes. The other thing that's interesting is the CoreOS team actually joined Red Hat because Red Hat acquired CoreOS several years ago now. etcd's role within Kubernetes is to store the configuration data of the cluster and to represent the state of the cluster at any point in time. This might make you think of the Apache Zookeeper project. etcd favors consistency over availability in the event of a network partition. This is in reference to the CAP theorem. So etcd will favor consistency and partition tolerance, not availability. As a site reliability engineer, that's an important thing for me to know. The reason that Kubernetes favors consistency is that consistency is crucial for being able to schedule correctly operating services. Data integrity is very important. Now let's talk about the Kubernetes API. The Kubernetes API uses the etcd watch API to be able to roll out configuration changes and monitor the state of the cluster. If there are divergences from the original state as declared by the developer, the Kubernetes API will also work with the etcd watch API to make sure that that state is rolled back to what it should be. Now let's talk about a pod. A pod is the basic scheduling unit in Kubernetes. A pod consists of one or more containers that are guaranteed to be co-located on the same node within that pod. Pods are designated with IP addresses. and they are how we are able to actually create our services, our replica sets. Everything really comes back down to the pod. So the way that I like to understand what a pod is think about it like this. If you know what Docker containers are, you can have a pod with one or more containers within it. You could have, for example, an Nginx pod. And within there, you could just have one Nginx container that is running within the pod. That Nginx pod is addressable via the IP address. The other thing that you can do is you can set up pods to be much more highly available by determining how many replicas of the pods you would like. So for example, we might like to say we want 2 replicas of that pod on each worker node. So this way, if something goes down, say if one pod crashes, then your service can actually reroute traffic to the other pod that exists on the server. Each pod is assigned a unique IP address within the cluster. This enables applications to use ports without conflict. Within a pod, multiple containers are able to communicate with each other using localhost, but one container within a pod cannot communicate directly with another container in a different pod. They have to use the pod IP address to be able to communicate with each other. But it's also important to know that pod IP addresses are ephemeral. So you shouldn't use pod IP addresses to create your applications. Think about it like this. If your pod goes down, if it's restarted, stopped, then when it comes back up, it will actually have a new IP address. This is similar to the idea of it being bad to hard code server addresses when you're building applications and writing your code, because servers can go up and down all the time and that can cause an outage. Instead, Kubernetes has other types of features that you can use to be able to write your code and make use of your different services and pods that you're creating. Instead of building applications to directly communicate with pod IP addresses, because they won't exist anymore, or that IP address might be being used for a different pod, you should instead use services. All Kubernetes pods should have a service name that you can reference, like for example, Nginx or Redis. This makes it easier to be able to find your pods as they restart and have new IP addresses within your cluster.